Here a, b are constant since we have to find dy dx as well as d2y dx2. Therefore, other symbols used, that means here a, b are constants. I have calculated here mentally, and my advice to the learner, students, you try calculating mentally. Now we have got y equal to this. Now we note that this is fraction form. Numerator is 1 and the two factors are linear factors. Therefore, if we take difference of these two factors, then difference will be a constant. Then we can apply distributive law and we can express y as difference or sum of two fractions. You note that. Difference is constant, therefore I can express this as 1/3 that is equal to y is equal to, now we apply distributive law, x by this, that means 1 by x minus 2 minus 1 by x plus 1. Therefore, we have expressed y is equal to 1/3 into, within brackets, difference of two fractions. Now, 1/3, this is x minus 2 whole to the power minus 1 minus x plus 1 whole to the power minus 1. Now we differentiate differentiating with respect to x. Left hand side will be dy dx and 1/3 is constant, therefore ddx of x minus 2 whole to the power minus 1 minus ddx of x plus 1 whole to the power minus 1. 1/3. Now it is u to the power minus 1 form. That means first derivative with respect to y, that will be minus 1 u to the power minus 2 means x minus 2 whole to the power minus 2 and ddx of x minus 2, that is 1. Therefore, I am not writing that one. Minus 1 whole to the minus 1 into x plus 1 whole to the power minus 2 into derivative of x plus 1, that is also 1. I am not writing that. Therefore, 1/3. This will be plus. Therefore, I take it this part first. X plus 1 whole to the power minus 2 minus x minus 2 whole to the power minus 2. Therefore, again differentiating to get second order derivative, 1/3 constant ddx of x plus 1 whole to the power minus 2 minus ddx x minus 2 whole to the power minus 2. That will be equal to 1/3. Again u to the power minus 2 form. Therefore, derivative of u to the power minus 2 with respect to u, that is minus 2 u to the power minus 3 into derivative of x plus 1, that is 1, not writing that, minus 2 x minus 2 minus 3 into derivative of x minus 2, that is 1, not mentioning that. I need space. Let me rub. Therefore, d2y dx2 is equal to, this will be plus 2, therefore I write that in front, and 2 is common factor, 1 x minus 2 whole to the power minus 2 minus 3, sorry, that means x minus 2 whole cube minus 1 by x plus 1 whole cube. This will be the second order derivative of this function. Therefore, we have found out the second order derivative. One thing, I have expressed y is equal to 1 by x minus 2 into x plus 1, that can be written also x minus 2 now. If we take this form and taking logarithm on both sides, we can also find first order derivative. In that case, the form will be quite complicated. That is why we have used the trick of expressing y as difference of two functions. Thus, the sum is solved. Next, second sum, y equal to sin square x cos square x trigonometric function using the concept of multiple angle form. This will be y is equal to 1 by 4 into sin square 2x. Then again we can also 1 by 8 2 sin square x form, that means 1 minus cos 2x form. Therefore, finally we get y is equal to 1 by 8 minus 1 by 8 cos 4x. My suggestion to students, while you are working out functions, trigonometric functions rather, first you note that function. If that can be reduced to simpler form or simplest form, you first do that. Otherwise, the sum will be quite complicated. Therefore, I have expressed here y as in the form of multiple angle form. Therefore, now it is easier. Differentiating with respect to x, dy dx, left side. Now, derivative of this one, derivative of first part constant, therefore that will be 0 minus 1 by 8 constant into ddx cos 4x is equal to cos function, therefore derivative will be negative. Therefore, finally it will be 1 by 8 into, again it is cos 4x, cos u form, that will be sin u derivative of 4x is 4, therefore 4 into 4 by 8 into sin 4x means 1 by 2 sin 4x. Thus we get first order derivative dy dx is equal to half sin 4x. Therefore, d2y dx2 half ddx Sin 4x half sin u form while u equal to 4x, therefore derivative will be cos u cos 4x into ddx of 4x. That means 1 by 2 cos 4x into 4. We simplify, finally we get d2y dx2 equal to 2 cos 4x. Now we have to find the second order derivative at the point x equal to pi by 4. Therefore, d2y dx2 that is represented by this symbol. At certain point, symbol is this one. Therefore, this will be 2 into cos 4 into pi by 4 2 cos pi, that means minus 1 minus 2. That is the answer. We can write that d2y dx2 x equal to pi by 4 equal to minus 2. Differentiating with respect to x, left side will be dy dx. Now right side cos of log x form cos u where u equal to log x. Therefore, we first differentiate cos u with respect to u. That means it will be minus sin of log x into ddx of log x. That is equal to ddx of log x 1 by x minus sin of log x into 1 by x. Therefore, dy dx is equal to, I can write that minus x to the power minus 1 into sin of log x. Product of two functions. Therefore, d2y dx2 is equal to minus fx. Derivative will be minus f dash x. That is why minus ddx minus u into v form x to the power minus 1 into ddx sin log x plus sin log x ddx x to the power minus 1. U into dvdx plus v into du dx form. Now we calculate minus x to the power minus 1, derivative of this 1 by log x into sin of log x, then it will be cos of log x, sin u form cos u into ddx of log x and for this part sin log x derivative of x to the power minus 1, that is minus 1 x to the power minus 2 Therefore, finally we get d2y dx2 is equal to minus outside it will be 1 by x square. ddx of log x 1 by x into 1 by x, 1 by x square into cos log x, then minus 1 by x square sin log x. Now multiplying that minus symbol and taking 1 by x square outside, sin log x minus also log x. That is the answer. Next, this one, fourth one, x square by x square plus y square by b square equal to 1. Apparently parametric form, apparently implicit form. The process will be just we differentiate both sides with respect to x. Here a, b are constant since we have to find dy dx as well as d2y dx2. Therefore, other symbols used, that means here a, b are constants. 1 by a square constant into derivative of x square 2x plus 1 by b square constant, then derivative of y square. Chain rule is to be applied. On the right side 1 means constant, therefore derivative will be 0. Or 2x by a square plus 2y b square dy dx is equal to 0. To find dy dx, we keep this dy dx term on the left side and the other on the right. 2y b square into dy dx is equal to minus 2x by a square. Then these two are cancelled. Therefore, dy dx is equal to minus b square by a square into x by y. Now we have to differentiate again with respect to x. I write here. Therefore, d2y dx2 is equal to ddx of minus b square by a square into x by y. Now, minus b square by a square is constant. Since derivative of c into fx is equal to c into derivative of fx, that is the rule or property. Now, into ddx of x by y. This is u by v form. Therefore, q by d, we start v square minus b square by a square, denominator y square, derivative of x is 1, therefore this will be y minus x dy dx. Now we have already got dy dx here, and we put that value in that expression. X dy dx means x if I take this as 1, here we mention using 1, that is equal to minus b square by a square y square into y minus means plus b square x square by a square y. I am simplifying. This expression is simplified. Denominator is a square y, that is multiplied with it, that is why a to the power 4 y cube. Numerator will be a square y square plus b square x square. Now you see, if we simplify this one, it will be b square x square plus a square y square equal to a square b square. Therefore, we replace that need space. Therefore, d2y dx2 is equal to minus b to the power 4 a to the power 4 y cube into, in place of this, a square b square. Sorry, this is b square. A square numerator at the numerator, a to the power 4 at the denominator. Therefore, after simplification, minus a square, minus in front, a square at the denominator, then b to the power 4 by a square y cube. That is the answer. Next is sum y equal to e to the power 4x into sine 3x. Since there is exponential form, I have chosen this one. To find the second order derivative, we proceed like this, differentiating with respect to x. My suggestion to the learner or students, while you are solving such type of sums, you mention that statement differentiating with respect to x. Actually, this is not so called ordinary operation. That is why my suggestion to you, better you mention this. Left side will be dy dx, right side u into v form. This is u, therefore we apply that e to the power 4x into ddx sine 3x plus sine 3x ddx e to the power 4x e to the power 4x e to the power 4x. Now ddx of sine 3x, chain rule is to be applied. Sine u form where u equal to 3x, therefore cos 3x into derivative of 3x, that is 3, plus sine 3x derivative of e to the power 4x e to the power u form e to the power u with respect to u into derivative of 4x, that is 4. I have calculated here mentally, and my advice to the learner, students, you try calculating mentally. Therefore, dy dx is equal to 3 e to the power 4x into cos 3x plus 4 e to the power 4x sine 3x. Now we take e to the power 4x common factor. You may not take common factor. 3 cos 3x plus 4 sine 3x. Therefore, here we can write directly d2y dx2. That means we are differentiating the product already we have got with respect to x. Now this is again u into v form, product form. Therefore, e to the power 4x into ddx 3 cos 3x plus 4 sine 3x plus 3 cos 3x plus 4 sine 3x into ddx e to the power 4x. E to the power 4x. Now derivative of that expression. First of all, 3 constant, cos 3x, cos function is therefore derivative will be minus 3 into derivative of 3x is 3, therefore 3 derivative of cos 3x is sine 3x. I have done mentally. Then 4 into 3 cos 3x 4 constant, derivative of sine 3x, that will be equal to cos 3x into derivative of 3x, that is 3. Then plus 3 cos 3x plus 4 sine 3x into derivative of e to the power 4x, e to the power u1, e to the power 4x into derivative of 4x, that is equal to 4. Now we simplify. E to the power 4x is common factor. We take it out. Minus 9 sine 3x plus 12 cos 3x. Then we have to multiply 4 plus 12 cos 3x plus 16 sine 3x. Therefore, let me check. E to the power 4x minus, okay. Then e to the power 4x is common factor within brackets 16 7 sine 3x plus 24 finally I write here, therefore d2y dx2 equal to 7 sine 3x plus 24 cos 3x into e to the power 4x. Next sum, if y equal to a cos nx plus b sin nx, then we have to prove this relation. I first write this one. Differentiating with respect to x, left side dy dx is equal to a b constants, therefore a into derivative of cos nx with respect to x, angle is nx, therefore first derivative of cos u where u equal to nx with respect to u, that is minus sin nx into derivative of, I just write it, plus b cos nx into dx of nx. Derivative of nx is n, therefore minus a n sin nx plus b n cos nx. This is the first order derivative. Now n is constant, therefore that can be taken outside. N b cos nx minus a sin nx. Again differentiating, with respect to x, left side d2y dx2, n constant, therefore n into derivative of the expression b cos nx minus a sin nx. Therefore d2y dx2 is equal to n derivative of b cos nx, b constant. Since there is cos, therefore it will be minus b sin nx into derivative of nx, that will be equal to n minus a cos of nx, derivative of nx is n, now minus n is common factor, therefore it is n square a cos nx plus b sin nx. Now you note that this is nothing but the original one, therefore d2y dx2 equal to minus n square y. Now taking this on the left, we get required result. Finally, d2y dx2 plus n square y equal to 0. Next sum is this: x equal to e to the power theta and y equal to sin theta. We have to find d2y dx2 at theta equal to pi by 2. Now it is clear that this is in parametric form. Therefore, first we find dy dx. X equal to e to the power theta. Therefore, dx d theta, that is equal to e to the power theta. Then y equal to sin theta. Therefore, dy d theta equal to cos theta. Therefore, we apply that formula: dy dx is equal to numerator dy d theta, denominator dx d theta. Put the values: cos theta by e to the power theta. Therefore, dy dx equal to cos theta into e to the power minus theta. I suggest my student, you write this is function of theta. Therefore, d2y dx2 is equal to ddx of cos theta into e to the power minus theta. Now this is function of theta. Therefore, first we have to differentiate that with respect to theta, dd theta of cos theta e to the power minus theta, chain rule, d theta dx. Note that I always suggest my students, you write that this is dy dx, x, y are variable, but on the right side theta is variable. Therefore, we cannot find directly. We have to use here the chain rule. I have applied that. Therefore, d2y dx2 is equal to, first I find the derivative uv form, cos theta derivative of e to the power minus theta plus e to the power minus theta into derivative of dd theta cos theta whole into d theta dx. Already we have got dx d theta equal to e to the power theta. Therefore, d theta dx will be 1 by e to the power theta. Therefore, d2y dx2 is equal to minus e to the power theta minus theta rather into cos theta, derivative of e to the power minus theta with respect to theta, that is equal to e to the power minus theta into dt theta of minus theta, that is equal to minus 1, finally this, plus e to the power minus theta into derivative of cos theta minus sin theta whole into e to the power minus theta. Now I take e to the power minus theta outside, then minus sign is also in both the terms, therefore e to the power minus theta into e to the power minus theta, therefore it will be note the calculation. Now at theta equal to pi by 2 we have to find, therefore d2y dx2 theta equal to pi by 2, that is equal to minus e to the power 2 theta pi, therefore minus pi into cos pi by 2 means 0 plus sin pi by 2 1, therefore finally d2y dx2 at theta equal to pi by 2 is equal to minus e to the power minus pi. Next term, y equal to tan inverse of this one. We have to find d2y dx2. First we note that y equal to tan inverse of this one. Already I have mentioned that in trigonometrical case, if you find such expression, first you simplify the expression within the brackets. Now 1 plus tan x by 1 minus tan x, that can be written as 1 is tan pi by 4 plus tan x 1 minus tan pi by 4 into tan x. Thus we get form tan alpha plus tan beta divided by 1 minus tan alpha tan beta. Therefore, this is equal to tan of pi by 4 plus x. Therefore, y is equal to, I write next line. Therefore, y is equal to tan inverse of tan pi by 4 plus x, that is tan inverse of tan theta, I have mentioned earlier, that is equal to theta therefore dy dx, this is constant, therefore derivative will be 0 plus derivative of x 1, thus dy dx equal to 1, constant, therefore d2y dx2 equal to 0, that is the answer. Then I take next sum, number 9. Y is equal to sin m sin inverse x restriction given mod x less than 1, then to prove 1 minus x square into y2 minus x y1 plus m square y equal to 0. What was it? We are going to solve that. Y equal to sine m sine inverse x. Differentiating with respect to x. Left side dy dx. Now right side we note that sine of u, where u equal to m sine inverse x, therefore derivative will be cos same angle, then dx of m sine inverse x, then cos of m sine inverse x, derivative of this one m constant, therefore m sine inverse x derivative root over 1 minus x square. Now dy dx is represented by y1, therefore now I take this on the left, that means root over 1 minus x square into y1, that is equal to m cos of m sine inverse x. Now we can differentiate both sides, or since there is root over matter, it does not matter, we can square both sides. Otherwise, if we keep it as it is, it will be a bit complicated. That is why I first squaring 1 minus x square into y1 square, that is equal to m square cos square m sine inverse x. Now you note cos square theta form, that means that equal to 1 minus sine square theta. I can write that m square 1 minus sine square m sine inverse x. Now that will be equal to m square into 1, m square minus m square sine square this. You see, sine m sine inverse x is there, therefore that will be m square y square. Note that, very interesting. We can replace, if we call 1, here we write by using 1, by using 1 just. Now we rearrange, what we get? 1 minus x square y1 square. I take this on the left, m square y square is equal to m square. Again we differentiate. Again differentiating with respect to x. Now this part first. U into v form 1 minus x square into derivative of this one, that will be 2 y1 u square form, that is y2 u into derivative of y1, that means y2 plus y1 square derivative of 1 minus x square, that is minus 2x, plus derivative of m square y square, m square is constant, into derivative of y square 2y into y1, that is equal to 0. Or now we know y1 is common factor, 2 is also common factor. We divide by 2 y1, then we get 1 minus x square into y2 minus x y1 plus m square y is equal to 0. Here we have considered y1 non-zero. Therefore, we have got that final relation 1 minus x square into y2 minus xy1 plus m square y equal to 0. So,